This is a presentation on the new features within Alphacam 2017 R1. This presentation will look at some general enhancements. Firstly, we're going to look at some changes that we've made to Automation Manager. The first one we need to consider is that with 2017 R1 we've gone to a new database version. What this means is that when you first start Automation Manager in 2017 R1 you will see this message. And that is to tell you that your database has been updated. Now what will happen is that everything from the previous database will be copied. Anything that you create in 2017 R1 will not be visible in 2016 R2 or an earlier version. Likewise, the databases are then detached, so if you created something new in 2016 R2 it wouldn't be seen in 2017 R1. The data from 2016 R2 will only be imported the very first time you run Automation Manager in 2017 R1. Regarding the feature extraction settings in Automation Manager, there's now the option when you're extracting contours from faces to also select to extract the solid body outline. Now in machining order, when not nesting, you are able to select a machining order from job, which we weren't previously able to do. You had to pick a defined list, whereas now you can use the settings on the main order. In layer mapping setups, you now have the possibility of copying and pasting, so you can copy a whole setup. So if you need to duplicate one and just make some tweaks, you can now copy the whole setup rather than having to completely tweak it. Copy and paste appears in various levels throughout the layer mapping setup tree. There's also been general processing improvements designed to speed up the processing of Automation Manager. In some instances we've seen some massive improvements in the time taken in order to process an order. Now looking at more general enhancements and improvements. On the input CAD, there is now an option for assemblies, so we can see a new tab, and on this new tab we have various settings that give us control over where we want to save the CAD files to, and also the naming convention for the files that are being used. We also have the option to import SolidWorks assemblies directly without actually the user having to use CAD links to export them. This does mean that all of the assembly files must be in one area. If they're not all in the same folder, then CAD links must be used. On Parametric Sketcher, we've now introduced the option to create the panel as a work volume, and we've made some changes to simulation, both the internal simulator and the external simulator. We've added the option for program stop. So if we look in the configure area for the internal simulation, we can see we have the option stop when program stop reached. And on the external simulator, in the stop options, we also have the option for stop at program stop. There were instances when running the simulation that in order to not sit there watching it for a long time, you would speed up the simulation so the toolpaths would be at the right speed, but this meant that the clamps would move very quickly, so you couldn't really get an appreciation of where the clamps were moving and how they were moving. We've now introduced a feed rate option onto the clamps, so now these will be affected by the simulation speed and can be slowed down accordingly. There's now also a new machine configuration option which wasn't available before. We now have the option to rotate the tool around the X-axis and the Y-axis, whereas before you could only do X and Z or Y and Z. Now also something else regarding the external simulation is a faster loading of 5-axis toolpaths. Before it's taking a little bit of time to process these and load it. This is now much faster. The offset command has been enhanced to introduce an option to offset on both sides. This could be quite useful if you have a single line for lettering. You could then offset this to both sides to give it a width to engrave that width. OvoFittings have been appearing more and more for people putting cabinets and pieces together. So it's an assembly fitting, and there's now an option within Alphacam to put in OvoFitting toolpaths. So these are configured in the correct size and using the tools to machine the part for the correct form for the OvoFitting. Area estimate has been improved. Before, it wasn't taking in the drilled holes area that's been machined out, so this has now been included. And there's a free option called drawing notes. It's an add-in, and when this is selected, even if there were no drawing notes on the drawing, it would always keep appearing every time you opened a drawing, whereas now there's an option that will only open with the drawing if the note exists. So let's have a look at these features now within Alphacam 2017 R1. Let's begin by looking at the Input CAD Assemblies option that we have now. So if I go to the Input CAD command, we're going to read in a SolidWorks assembly. So I go to the Assembly tab, and I have the options here to save each solid body. So as we read it in, it's going to save each part in the assembly out to a separate Alphacam drawing, which allows us to maybe add parts to a nest list or process through Automation Manager. And obviously we can align each body as we're outputting it as well. We can save these to the default Alphacam CAD folder, or we can output to a custom folder, and you can browse for the specific pathway. We have various options regarding the file names, so we can use the actual name of the solid body, or we can start to append or prepend names onto them as well. We're happy with that, we can click OK, and we now need to go and browse for our file. So I have a collection of SolidWorks parts, but it's the actual SolidWorks assembly that I'm going to read in. So we say OK to that. It reads in the part, and then it actually saves all the individual parts out. So it's found 25 individual parts within that assembly and saved them all to my output folder. So I can say OK to that, and then I'm going to go to File Open. I don't need to save the actual assembly itself, and let's go to my output folder. And now we can see we have all of the individual parts of that assembly. So these are now ready for us to process in some other way. Now we're going to look at some simulation settings, beginning with the program stop. So we can see we have our list of operations. We have a program stop after the drilling. So if I go to simulation, turn this on, click play, you can see the simulation working, and it just goes on and it hasn't stopped with our program stop. That's because we need to add in the option for this. So let's just stop the simulation. We go to configure. We have the option here for stop when program stop reached. Say OK, and then we'll run the simulation again. And now we can see we're indicated in this area here with the program stop is active. Then we can obviously continue the simulation. So that's the setting on the internal simulator. If I actually now stop that, and let's right click and go to the external simulator, we can see the program stops in our sequence browser. If we press play, the simulation goes ahead and it stops. And that's because in the stop options we have this setting active. Without that ticked, then obviously it would continue through the program stop. The next part of simulation that we're going to look at is the speed of clamp movement. So we can see we have a machine defined here with clamps. We've got some movable clamps on here and some operations showing the clamps moving. So if I just press play and start the simulation, we have obviously control over this, and I can slow this down. But part of the problem is that sometimes you want to speed up the simulation so you can see the toolpaths working quicker. If I speed this up too fast, the clamps move really quickly. So if I press play again, we get no appreciation really of what the clamps are doing. So what we want to do is obviously have a bit of control over that. We've introduced in this version the option to actually add a feed rate to the clamps. So let's have a look at that. So if I go to the layers, I need to go and find my movable clamps. So if I look at this section to start, edit the clamp definition, we can see we have an area now for feed rate. I'm going to add a feed rate to this clamp, say OK, and continue through the other movable clamps. Now I've come to this clamp and the feed rate is actually greyed out. This is because the feed rate is irrelevant because the clamp is not defined as movable. So you only get the option to edit the feed rate on movable clamps. So if I now go look at all of my other clamps that are actually moving and edit these as well. Now that's done, let's watch the simulation again. You can see it's now moving very slowly. So if I now speed this up to what would be an acceptable level for the machining, we've still got good control over seeing what the clamps are doing. So this gives us much more flexibility over watching the speed of the simulation and seeing how the clamps are going to move as well. The last part of simulation we're going to look at is the new machine configuration that we've added. So we can see we have a machine on screen. If I just go and edit the machine configuration, we can see the settings that we have for the machine. So before, we've been able to rotate the tool around X and Z or Y and Z, but never to give the ability to rotate the tool around X and Y. So we can now see we have this setting available to us. So I'm going to say OK to this. It's not a very common machine configuration. It's not something you see so much on milling machines or routing machines because it's not very rigid. It's more common to see in water jet, plasma, laser cutting machines. If we run the simulation, we can see how the head is moving. We can see that we have the tilt and the twist working over the X and the Y axes, which gives us this movement as we can see here. That just gives us a lot more flexibility in defining the actual machines that we will see in the real world. We're now going to take a look at the change we've made to the offset command. I'm just going to start by machining the geometries that are on screen. So I'm just going to go to my machining styles and apply the style. If we run the simulation, we can see the type of machine that we've got, where we've basically machined the whole pocket away to give us the lettering that we want. So I just want to change that slightly to have more of an outline lettering, but rather than just do single geometries and cut along those and give the width to the tool, I want to define the width. So I'm just going to undo that machining and take a look at my geometries a little bit closer. So I'm going to activate the offset command. So if I go to edit, offset, and we can now see that we can specify the distance as always, but we now have the tick box option for offset on both sides. So I'm going to delete the original because I won't want the centerline geometry anymore. I'm going to say OK to that, and as we click the geometry, we can see how it offsets on both sides and then deletes the one in the middle. So I'm just going to work through my geometries and do that. And now when we've got that done, I do need to change my tool directions to give me now the option for pocketing. So if I go to machine, tool directions, I can go automatic for pockets on all geometries. And let's go back and reapply my machining style. So we can see the machining's applied. If I now have a run of the simulation again, we can see the difference in the machining. So it just gives us the material left in the middle of the letter. So we've got a thickened outline. So this is what offset on both sides can do, amongst many other uses. Now we're going to have a look at the free add-in for OvoFittings. The OvoFittings macro is not actually installed with Alphacam, but it is available on the DVD. If you browse the DVD and go to the Extra Add-ins folder, there is an OvoFittings folder, and in there is an installation routine that will install the macro and the relevant files that are able to be used with it. These fittings are a push-fit connection system for joining materials together. And if we have a look in the images, we can see how these work. We need to get this machining in Alphacam so we can machine these features into our pieces that we need to join together for the fitting to then attach. So if we now look in Alphacam, I can go to my File Inserter tab. When we install the macro, we get some sample clips inserted already. So with my File Inserter, I can add these to my drawing wherever I require. And this inserts the outline of the fitting and the machining. So if we just run the simulation, we can see the type of tool that's being used. Obviously just comes along, machines in, and then comes out the part to create the fitting or the hole for the fitting to push into. We can just simply insert the fitting into the drawing if we want, but if we have solid models, for example, we can then actually detect the feature within the solid and then insert the fittings automatically. Now looking at the solid model within Alphacam, we can see we have the features that we want to put the OvoFittings into. So we need to start by going to the feature extraction to find these. So if I go to solid model extract and then automatic extraction, we're not looking for any drillable holes. I'm going to search for just contours. I'm going to look in all bodies, there's only the one solid in the drawing, and we're going to work from faces. And if I configure the faces, I want to say all planar faces. So when we've done that, we can say OK. The feature extraction will now find those features for me. So what we now need to do is basically insert the fittings. So we need the OvoFittings command. Well, as I mentioned, this is an add-in that I've installed, but it's not yet turned on. So if I go to add-ins and then turn this on, it should give us a command on the machine menu. If the command isn't there, then you may need to configure your ribbon bar to basically add the icon in. So once this is done, I can click this command, and now we can go around and individually click the fittings that we want, but if there were many in there, we can say all, then we'll say finish. I now get a warning coming up basically telling me that some of the geometries I've picked are invalid. This is because it's picked up on the outside rectangle, and it's telling me that it's not the right type of geometry for an OVO fitting, so it will be ignored. And we'll say OK, and it's now attributed the correct fittings to the relevant size of feature. We can now see the machining operations, and if we run the simulation, we can see the machining is going in for the horizontal fittings and also the vertical ones. The last feature that we're going to look at is the change we've made to drawing notes. As I mentioned, drawing notes is a free add-in, so if I go to my list of add-ins and turn it on, we can now go back to the Home tab and see that we have the option here for drawing notes. So if I select this, I get the dialog appear, and this allows me to enter a note. So when I save the drawing, this information will be saved with it. The issue we had is if you had the drawing notes turned on, even if you didn't add a drawing notes, this dialog would still appear. Well, you don't want it appearing if there's no message inside it. So we have this tick box option here that says only open with a drawing if the note exists. So I'm going to say OK to that and save the drawing. And now when I close the drawing and go reopen it, so I'll go to my recent documents, we can see that the drawing note appears. So if I actually delete that and then say OK, save it again, get rid of the drawing, once again reopen from recent documents, we can now see that the drawing note doesn't appear.